Okay, this is the most famous classification system, rock mass classification system. Then we discuss all that, the system. So rock mass classification system very useful, very practical in engineering tool for rock mass classification, especially for tunneling. Uh, so this one is provide starting point for design of tunnel support and also for other structure, for example, rock slope or foundation in rocks. So and force user, the system force user to examine the properties of rock slope or rock mass in systematic manner. So because since there is the system, so everybody have to follow the system. Everybody have the system to follow. So net yeah. So comparison can be made because since they do the same procedure, so we are able to compare. Okay, and then rock mass properties. Okay, rock mass classification, we are discuss on rock mass properties, not on single rock properties. Rock mass properties and rock properties is very different. Since we are rock mass here, mass is mean big size. So since they are big in volume, so the properties of this rock is combined a few parameters. First is strength of rocks. This is strength of intact rock, small samples. Uh, and then we also consider the spacing of discontinuity, numbers of uh, joint set, and properties of structural properties. Main is like, for example, the persistent aperture, water, roughness. All these things is called that properties of discontinuity. So and also the deep direction and deep angle of discontinuity inclination, also groundwater or in situ stresses, and also orientation of the structure in the slope, or whether slope or the tunnel. So meaning that here we are consider many parameters. That's why this rock map properties is more uh, we are practice this for our design of tunnel. Yeah. We using this one to design our tunnel. So this what is mean by discontinuity? Discontinuity in definition is fractured within the rock mass, which cause the tensile strength of the rock to zero, yeah, or close to zero. Okay, so here the strength is almost zero. We're talking about tensile, yeah. Tensile mean is pulling apart, so the tensile strength is almost zero. So this is how a rock mass looks like, the properties of the rock mass, which is we start from here. We can consider as a persistent mean length of the fractured joint, or we'll call that length, wall strength of the rocks wall, in the joint strength. We can do this to get the joint of the wall strength. We can do this rebound hammer test. Rebound hammer test is we can get the compressive strength of the surface of the rocks. Okay. Also, we can do this. The properties is infilling material. Infilling materials. Infilling material means here is what type of material uh, within this the fracture, and also this discontinuity type of discontinuity, whether it's padding, fault, joint, foliations. All these things we consider as a type of discontinuity. Roughness, uh, roughness, and this is how the roughness, the surface of the joint. Yeah, we look on the surface of the joint. This is roughness. Block size, block size is dependent on the spacing of discontinuity. If you are very close spacing means the block size is very small, and if you have large spacing mean the block is okay. We have a seepage where the water is any water there in this fractured aperture. Okay, aperture, rock type, orientations, numbers of sets, and also spacing. This is the properties of rock mass that you can see in our lab 4. Lab 4 in our assessment we are only consider deep direction, deep angle. But in that data sheet we also have the this all this information. Yeah. To understand that, for example, plana, yeah, plana. This is they're talking about the roughness of this joint. You can see plana, wave, or step. So this is how this surface of joint looks like. Some of that is plana, wave, or step. So if we have step surface of joint, so normally it's very this shear strength is higher compared to plana because it is a step. Okay, persistent is how long this discontinuity. If you have very long, very persistent is very long, so mean that we have the uh, is more critical than this shorter persistent. Yeah, yang panjang. And so type of infilling. So infilling material is very important aspect. So if you have very cohesive material, for example clay infill, so it's more dangerous than sand infill. Okay, and also roughness. So to understand that what is discontinuities, so discontinuity is formed from several process lah. If you are looking on sedimentary areas and sedimentary rock, there are difference. For sedimentary rock, normally bedding plane because of depositions of sediment. Bedding plane itself is as a discontinuity. Some of that because of tectonic deformation, tectonic movement. We have folding, joint, or fault. So we have that kind of this discontinuity in sedimentary rock. This is a sedimentary rock layer. This layer we call that as a bedding plane as a discontinuity. A fault also as a discontinuity, but this fault is experience movement. You can see here this block is moved. So if you can see the surface of this fault, you can see the movement, a sign of movement, where you can see the silicon sided. Okay, full is part of this discontinuity. So in igneous, where is discontinuity come from? Come from the cooling of magma. We have joined, for example, in volcanic rock. So we have this column like this column. So in tectonic, due to tectonic is joint or fault, similar to like in sediment. But we have another one which because of weathering, they produce sheet joint. Sheet joint is part of this discontinuity. So this is joint. This is rock. Rocks outcrop. You can see the joint here. Okay. So this all joint same directions. So this is a sheeting joint because of the weathering. Okay, see. Okay. I already show another example in Kinabalu. The mount of Kinabalu, we have a sheeting joint in granite. So also metamorphics, we have the recrystallization of mineral, alignment of mineral, create foliation. So this is part of this discontinuity in metamorphic rock. So